Hello, my name is Muhammad Faiz bin Muhammad Anwar with matrix ID SB21028. We, Group 10, are going to talk about reaction rate. But before that, we must understand about chemical kinetics first. What is chemical kinetics? Chemical kinetics is the study of the speeds of reactions, whether it is fast or slow, at the nanoscale pathways or rearrangements by which atoms and molecules are transformed from reactants to products. Actually, chemical kinetics are applied in our life. Let's say we want to eat instant noodle. During cooking, we do not realize that chemical kinetics are related with cooking. Some criteria to be fulfilled are how fast the noodle can be cooked and how the atoms and molecules in the ingredients are transformed during the cooking reaction to become an instant noodle. So that is all about chemical kinetics. Note that reaction rate definitely involves chemical reaction. Chemical reaction is a process that leads to the transformation of one set of chemical substance to another. Chemical reactions involve both reactants and products. Homogeneous reaction occur when reactants and products all are in the same phase, like gas or solution. Now the question is, what is reaction rate? Reaction rate or rate of reaction is the change in some measurable quantity per unit of time, or also known as delta X. For a chemical reaction, the reaction rate is defined as the change in the concentration of reactants or products per unit time. Time can be measured as hour, minutes, second, day, and etc. etc. So that's all from me. Thank you.
Hello, hi, my name is Lishalini K. Murugan. My metric ID is SB21015. I'm going to give a talk about what is rate law. So when studying a chemical reaction, it is important to consider not only the chemical properties of the reactants, but also the conditions under which the reaction occurs, the mechanism by which it takes place, the rate at which it occurs, and the balance towards which it proceeds. According to the law of mass action, the rate of a chemical reaction at a constant temperature depends only on the concentrations of the substances that influence the rate. The substances that influence the rate of reactions are usually one or more of the reactants, but can irregularly be a product. Another influence on the rate of reaction can be a catalyst that does not appear in the balanced overall chemical equation. The rate law can only be experimentally determined and can be used to predict the relationship between the rate of the reaction and the concentration of reactants. So the rate law equation is given here. So the R is reaction rate expressed in concentration over unit of time, which is usually used as M over S equal molarity over second. K is the specific rate constant. A and B are molar concentration of reactants, which expressed in M moles of solute over liters of solution. So last is N and M are orders of the reactions.
Hello everyone, my name is Tiosin Jin. My metric ID is SB21014. As my friend mentioned just now, the rate law has an equation of rate equals to K times concentration of A power M times concentration of B power N. From the equation, the reaction rate is dependent on the concentration of the reactants as well as the rate constant. We can determine the reaction order based on the value of M and N. The reaction rate for a given reaction is a crucial tool that enables us to calculate the specific order of a reaction. The order of a reaction is important in that it enables us to classify specific chemical reactions easily and efficiently. Knowledge of the reaction order quickly allows us to understand numerous factors within the reaction include rate law, units of the rate constant, half-life, and much more. Reaction order can be calculated from the rate law by adding the exponential value of the reactants in the rate law, which reaction order equals to m plus n. If you have a reaction order of 0, this basically means that the concentration of the reactants does not affect the rate of reaction. There are several different methods which can be followed in order to determine the reaction order, which include initial rates method, integral method, differential method, and so on. For the rate of reaction, it has an equation of rate equals to delta concentration divided by delta time, where delta concentration is the difference between the concentration over the time interval. For a reaction in the form of A plus B produce C, the rate can be expressed in the terms of the change in concentration of any of its components. For example, rate equals the negative delta concentration A divided by delta T equals to negative delta concentration B divided by delta T equals to delta concentration C divided by delta D. When the coefficients of the reaction are different, for example, A plus 3B produce 2D, it is clear that the concentration of B decreases 3 times as rapid as the concentration of A. The rate of reaction is customary to divide each change in concentration by appropriate coefficient. For example, rate equals to negative delta concentration A divided by delta T equals to negative delta concentration B divided by 3 delta T equals to delta concentration D divided by 2 delta T. That's all from me. Thank you.
Hi, my name is Raudata Ashiki Binti Shamsa Azhar. My ID is SP21113. So today I will present to you about the effect of concentration on reaction rate. So let's go. Number 1, the effect is reactant concentration. Reactant concentration, increasing the concentration of one or more reactants will often increase the rate of reaction. This occurs because a higher concentration of reactant will lead to more collisions of that reactant in a specific time period. Second, physical state of the reactants and surface area. If reactant molecules exist in different phases, as in a heterogeneous mixture, the rate of reaction will be limited by the surface area of the bases that are in contact. For example, if a solid metal reactant and gas reactant are mixed, only the molecules present on the surface of the metal are able to collide with the gas molecules. Therefore, increasing the surface area of the metal by pounding it flat or cutting it into many pieces will increase its reaction rate. Number 3, temperature. An increase in temperature typically increases the rate of reaction. An increase in temperature will raise the average kinetic energy of the reactant molecules. Therefore, a greater proportion of molecules will have the minimum energy necessary for an effective collision. And last but not least, presence of catalyst. A catalyst is the substance that accelerates a reaction by participating in it without being consumed. Catalysts provide an alternate reaction pathway to obtain products. They are critical to many biochemical reactions. They will examine further in the section Catalysts. Thank you for me and my group. Thank you.